All right, hello everyone, and welcome to today's webinar. It's titled "What's Inside My Containers," hosted jointly by Amazon Web Services and Sysdig. My name is Omar Lari. I'm a Partner Solutions Architect for AWS. I work on our container ecosystem and work with partners helping customers adopt containers on AWS. I'm going to be your host speaker today. So just to start, a couple industry shifts that we've seen as more and more customers have started to adopt AWS and cloud computing. Some of the major trends that we see here. First one is elasticity. So basically means that you can provision just the amount of resources that you need for your workloads, scale out and scale back in, and only pay for the infrastructure and services that you need when you need them. When it's underutilized, you go ahead and just return the capacity and stop paying for it. Next major trend we see is around agility. So you have the ability to spin up many different resources along the infrastructure side and services really quickly and rapidly, basically with the click of a button. Maybe you want to test out the new ideas, re-architect existing services. The point is that you don't have to wait for infrastructure to show up in your data center. The services and infrastructure are available to you on demand at the click of a button. And then lastly, high availability. We have multiple data centers in multiple regions across the world, so you can architect your application to take advantage of that infrastructure that's available to you and make sure that your applications are always up and running and they're close to where your customers are. So a lot of customers have started to adopt cloud computing. Another step that we're starting to see now is to start adopting containers. Basically, what a container is taking advantage of some core Linux constructs around C groups and namespaces. This allows you to allocate resources to processes, and the namespaces allow you to isolate those processes from one another. All of your application code, libraries, and dependencies are packaged up into a small package where you can run both the same application on your desktop as you do in the cloud. So adding to some of the points you see on the slide here regarding some of the benefits, containers are immutable, which means you never log into a container and make changes. You always make a change to the container image itself and then redeploy. This provides you with the confidence that you know that the application is running the same in all of your different application environments. So what does this mean to you? Another trend that we're seeing as customers use containers is that they're also adopting microservices. I think a lot of the people on the webinar today probably know what microservices are, but just to recap, it's basically a way to break up the application and the teams that develop and support those applications into smaller segments. So adopting microservices in containers means that this application's been broken up. You can make smaller, more frequent deployments to get features out to your customers and users at a higher velocity. In addition, it enables you to automate these processes. So this gives you the comfort to be able to make more frequent deployments into your environment. And so, some of the benefits that you get around deploying your container applications into AWS, first is the integration into all of the rest of the AWS services. So we have a full spectrum of services, things like DynamoDB and RDS to store your persistent data, SQS for queuing, Kinesis for streaming, additional tools for management like CloudFormation to deploy, CloudWatch for monitoring and logging, Elasticsearch for analyzing those logs, and a ton of different services just around compute, networking, analytics, mobile, to really help customers be more productive. Another thing is that we continue to add these capabilities at an accelerating pace. If you look back to 2011, we released over 80 significant services and features. In 2012, that was nearly 160, and the number just continues to increase. Last year, in 2016, we launched 1,017 new services and features. And so customers have access to this, whether they want to use them or not. It's just available to them. So continuing to leverage those really helps your teams be a lot more productive. Also, as I alluded to earlier, around the high availability, we have a global footprint. So you can deploy your container applications in any of our 43 availability zones that are spread out across 16 geographic regions across the world. We also expect to have 3 additional AWS regions come online through 2017 and 2018, and we recently announced France, China, and Sweden to be coming on through 2018. The next point is security. So we've achieved a number of internationally recognized certifications and accreditations that help customers achieve their specific security and regulatory objectives. There's tools like CloudTrail, KMS, Inspector that really help customers lock down their environments and have the same kind of security controls that they're accustomed to. And then lastly is the partner ecosystem. So we have a rapidly growing partner ecosystem that provides customers with software solutions that extend AWS and system integrators that can help customers deploy and manage those container applications into AWS. This is kind of the container ecosystem from the partner side. So if you kind of look in that middle area, we have a section that highlights orchestration, management, and scheduling. So this is managing basically clusters of compute resources that schedule and place your container workloads onto infrastructure resources. And then on the top blue box is our networking, security, continuous integration, and deployment partners that help customers accelerate their adoption of AWS and containers on AWS. And the partner that we're going to look at today kind of fits in that top box, Sysdig. And I'd like to introduce Knox Anderson, who's our technical partner here to cover the Sysdig product.
Awesome, thanks for the intro. Hey everyone, really excited to be presenting to you guys today. We want this session to be as interactive as possible, so if you have any question at any point in time, please chat that in and we'll try to address it as we're going through the presentation. So what we're going to cover today, so we're Sysdig, we're the container intelligence company, and we're going to be able to provide you a unified way to monitor, troubleshoot, and secure your containers from a single instrumentation point that's running on your host. So we're going to start off by talking about security monitoring and operations with containers in your environment, the challenges, what you need to know, and then from there, move on to our architecture, talk about the capabilities that that gives you, and then spend a ton of time today in the demo. So we want to get through the slides kind of relatively quickly, and then we're going to do some live installs, look at Kubernetes environments, ECS environments, all that kind of stuff. So a little bit of background onto the company. So we are founded by Loris Dejuani. He's the co-creator of a really popular network packet analyzer tool called Wireshark that a lot of you guys have probably heard of. That company was then bought by Riverbed. And from there, he built Sysdig. And Sysdig is the kind of like if you combine Strace, TCP dump, HTOP, LSOF, and some container magic on top, and it allows us to do really deep troubleshooting inside your containers. We launched that in 2013, have millions of downloads, and have built security and monitoring products on top of that core technology. We've got 250 plus enterprise customers and partner really closely with all the different orchestrator providers, as well as AWS and other companies. So like any other infrastructure shift, so physical to virtual, virtual to cloud, and now containers, it's going to create a need for new tooling. So first off, the things that make containers great, they're isolated, they're portable, they are essentially black boxes, also make it really hard to get visibility into what's actually running inside that container. Another benefit of containers is they're going to let you push things through your CI/CD platform quicker and make your development organization much more agile. That speed is something that your tooling really needs to adapt to and do more auto discovery and recognize the processes, containers, the C groups, everything that's running on your machine. Also with this shift, it really fragments your tool set. So you've got your legacy kind of host intrusion detection systems, maybe something for network firewall, then you've got a logging tool, a infrastructure metrics tool, all those different things with multiple points of performance overhead as well as management overhead on your team. And then last, the thing that really is happening with containers and allowing you to get to these nice scale-out architectures also makes it harder to make sense of what's running inside your environment. So now that database that was running on one host is sprinkled across multiple hosts and containers in multiple regions. How do you make sense of that service as a whole, look at its performance, and secure it? So the approach that we like to take, and we've seen a lot of other companies take, is a container native and cloud native approach. So really trying to get full visibility into what's running inside your containers without going and instrumenting any of those containers individually by themselves. You also need automated, adaptive, and alerting and security policies. So when you spin out that ECS cluster to 2 new regions, your alerting will automatically adapt to that, and also you'll have security and policy enforcement. That's going to scale as your applications scale. Next, with a non-disruptive unified instrumentation, you don't want to go and configure exporters in each container. These containers could be running for seconds, minutes, maybe hours, and you don't want to have to go and add extra libraries, dependencies, all of that to your containers, because then you're kind of getting away from that purpose in the first place. You're adding libraries, you're adding bloat, and you're getting away from that single process isolation. And then all of your security and monitoring needs to be fully service and orchestrator aware. So understanding how ECS is distributing your containers, how Kubernetes deployments are working, any orchestrator that you choose to run on Amazon, and understand that and be able to give you topology maps and different lenses and things like that. So next, I'm going to cover our architecture, a little bit about how we get data from your system and how we're able to see inside your containers. So our architecture is made up of 2 main components. The first would be container vision, which is going to allow us to see all app activity, container activity, host, network from a single instrumentation point. And then service vision, where we're going to go and pull all the APIs from Amazon, Docker, Kubernetes, OpenShift to go and enrich all the data that we collect from your hosts with that metadata from those services. And that's all sent to a backend, which you can use as a SaaS service that we'd host, or host it on-premise behind your own firewall as well. And from that single instrumentation point and single backend, we're going to give you security, monitoring, and deep troubleshooting and introspection capabilities as well. So the next section here, and this is kind of the thing that we're doing really differently, and I expect you guys are going to have a lot of questions here, so please chat those in. How do we actually collect data from these hosts? So what we're looking at now is a simple VM. I've got a host OS, a couple containers that are running, and what we're going to do is install our agent as a container or a process that's running on that host. That's going to allow us to instrument your kernel, and from there we're going to be able to see all the system calls that are happening from your containers. And so from there we're going to put all those system calls in a non-blocking read. This kernel module is fully open source, and it's part of our Sysdig open source product, Sysdig Falco, Sysdig Monitor, Sysdig Secure. And from there, we're going to be able to see all application activity, container activity, network system calls, all that kind of stuff from that kernel module, put it into a ring buffer, and then send that out to our agent so you can get your performance metrics, captures, events, all that kind of stuff. Before I get to the next slide, any questions on kind of how we instrument your host and the data that we're collecting there? All right, so I got a question about the overhead of the Sysdig agent. Yeah, so we just look at the process and kind of trace from there. And so that's going to basically let us say really performant. We usually run between 1% to 2% of the host CPU. Yeah, so 2 other questions here. Our agent, it runs as a privileged container, and we're actually looking at all the system calls and the C groups and namespaces that are happening on that host and from those containers to discover kind of what's running inside. So we're not looking at the Docker socket or anything like that. We're listening to the system calls and from what's running inside the container. Awesome. Justin, Jonathan, Jeremy, Christopher, thanks for sending the questions in. Look forward to kind of covering the next ones here. So on top of this instrumentation, we've also layered on an open source rule engine from Sysdig Falco, and this is going to allow you to do any policy detection and violation for files, directories, ports, executed programs, all that kind of stuff. So really customize any one of these open source policies to do any type of detection of user activity, application activity on your host. And then from here, we've also layered on some policy enforcement where you're going to be able to kill a container to kind of block that issue, or go and pause the container to quarantine it, or take a Sysdig capture, which is actually going to give you a buffering capture of all the system calls pre and post policy violation that happened in your environment. The next component of service vision, a lot of you guys are probably deploying architectures that look like this. So you've got a bunch of shared hosts running on EC2 that have container services sprinkled across them. And so what you need to do here from a monitoring or security perspective is enrich that data with the logical services that are running. So then you get a view of your environment that's running here on the right. So you can see the different services and enforce it at one logical level to answer something like, what's the response time of my Cassandra service that's distributed across 3 different AWS regions and made up of 50 different containers. All right, so next I'm going to talk about kind of where we sit in the container security stack. So we're really focusing on runtime security and forensic security. On the runtime side, we're looking for fundamentally malicious behavior. So if a user goes and runs a shell on a container, or if there's a write below etc, or if someone has modified an RPM database. So really looking at kind of the activities that are happening on your containers and on your hosts while you're running them in production. And then also, since we're monitoring millions of containers with Sysdig Monitor, we have a ton of data that we've collected about what the profile of a Redis container looks like in production, or what the profile of an Nginx container looks like, and then automating and updating policies to block those and alert you on anomalous behavior there. The second would be forensic security, and this is by default tracking every single user interaction that's happening on the host or within the container, and giving you full context of when your developers are pushing out new applications and things like that on ECS, all the commands that they're entering to a specific task or on a host, really however you want to slice and dice it in your environment. Also on the forensic side, doing that Sysdig capture, which I kind of like to describe as a TCP dump of your kernel, where we're going to be able to see all system calls pre and post policy violation and drop that into an SCAP file so you can do any type of analysis that you want there. We're going to integrate with your existing IT security tools, so logging, your SIM, and be able to send all of that data from Sysdig Secure out to whatever you're running. And then also on the platform side, we'll integrate with your different scanning tools, RBAC or secrets management, so then we can use that metadata and events from those systems in our events feed as well. On the monitoring side, you got to remember it's that single instrumentation. And I'm actually going to do a live install later to kind of show you different ways to get visibility on the host. But going in and dynamically mapping your services, so you can kind of abstract away your hosts and your containers and just see how that ECS load balancer is communicating with your different backend services that could be on RDS or Dynamo or any of those other things. Also going in and automatically detecting that MySQL is running, that Nginx is running, and pulling metrics from those services, as well as automatically detecting things like StatsD, Prometheus, JMX. So then you can pull metrics from inside your containers without having to go and instrument them. And then the last part that Sysdig Monitor will provide is we'll also integrate with all your CloudFormation templates, all that kind of stuff, so then you can logically surface data to your teams based on the services or the hosts that they're managing, so they kind of don't have to go through a bunch of different dashboards or hit different areas to get the data that they need and that's related to them. So hopefully that's kind of a quick overview. What I want to do now is kind of move over into a live instrumentation. And one of the last things I just wanted to cover quickly, this is something that we've done with hundreds of different companies across a bunch of different verticals, on-premise or with SaaS. And we really want to partner with you guys as you go forward in your container journey. All right, so now to the fun part, getting into the demo. So what I'm going to do now is something that you probably won't see from any other monitoring or security product out there. And let's actually do a live instrumentation of some containerized services that I've got running on Amazon. So if you can see in here, there's no data going into my environments. And if I go to my host really quickly and do a Docker PS, I've got a simple WordPress application running here, kind of like any other demo that you've seen. So we've got an HA proxy service, a bunch of WordPress containers communicating to MySQL. And I can go here and now kind of install this agent as a container that's running on the host. So let me see if I can. All right. Sorry about that, you guys. Didn't have screen control. Can I get a confirmation that everyone can see my screen now? Awesome. All right. Everyone can see everything now. Cool. So going back, I can just do this Docker PS again here. You can see, yeah, I've got a basic HA proxy service, some WordPress services, my SQL running here. And now I can go and copy this agent command where you can deploy it with ECS, with the daemon set via Kubernetes, really however you want. And I'm actually going to flip over into Monitor really quick so we can see the real-time data come in. So let's copy this command, and I'm actually going to remove the -d here so we can look at the output and see what's happening. All right, so what's happening right here is we're going to load this module via DKMS. So we're going to see the existing version of your kernel that you're running and then build that module on top of it. So it's not going to require a restart or do anything like that. And then you're going to see a bunch of different checks that are happening here. So starting to capture command lines, looking for any custom JMX metrics, Prometheus metrics, looking for all those different protocols to detect if anything is running there, and then start automatically instrumenting your JVM. Then we're going to go hit your different AWS instances, see if we can collect metadata there, pull Kubernetes metadata, Mesos metadata, really whatever you're running, auto-detect that and start pulling those metrics in. So if you're looking at the background now, you can see that I had a host pop up here. And if I open it up, you can see those same containers that we're running, individual performance metrics about all of those containers. And then from here, we can actually go in and do some further analysis of, okay, what's actually running on this host. So I can click on this network traffic map here, and I can see all my different ingress and egress services, the connections coming in, the connections going out, and then actually drill down inside of this host as well. So what we're looking at now is all the different processes that are running, the connections out, and then I can go into any container, see all the dependencies between them, and then actually drill down into any container and get down to the individual process level of what's running inside. So pretty much every other tool is just going to hit the Docker Stats API, and they'll say, hey, this container is running at 80% CPU, but not the process that's actually running inside and what's causing it to run at that level. One of the other kind of cool things from a security perspective that you can see here is I can actually even see the SSH process that I have running on that remote EC2 instance, and then the connection out from my local laptop here. So this is kind of our ISP provider that we've got at the office. On the application side, we can see that MySQL is running here, and switch over to kind of one of those default MySQL views, and we'll automatically detect that profile and then start pulling things like number of requests, number of errors, top queries, slowest queries from inside that container without you needing to do any instrumentation. So what's actually happening here is we can see that TCP connection, and we're decrypting it and then reading the file descriptor to pull all of these metrics out for you out of the box dynamically. All right, cool. So now that we've covered a little bit on the monitoring side and the instrumentation there, let's go into my host and do some stuff that we never should. So I'm going to do the docker ps command again really quickly, confirm we've got everything that's running here, and then let's go touch a binary directory. So I'm going to touch bin. Omar is hacking me. Sorry, Omar, for throwing you under the bus here. And I can do that and then switch over to Sysdig Secure. And if I go over into the Events tab here, and let's just switch this to the last 10 minutes, we can see, all right, we detected a right below that binary directory. I automatically discover that host and the containers that were running there. And then I can click on this and see full details of what happened, the user, the command, and all the full details of what happened around that policy violation. You can also flip over to the commands history and see everything that I've run on that host at that point in time. So quick overview here on the instrumentation side. Just really wanted to show you guys kind of how easy it is and how we kind of go and take a different approach to collecting that data from your host, and how that single agent can give you kind of full security and monitoring visibility into your containers, your services, and your hosts that are running there. All right, any questions about the instrumentation and what I've shown so far before I pop over into ECS? All right. Let's move on over. And just as you guys going, if there's anything that you have a question about how we're doing detection or metrics or anything like that, please send those in as soon as it's going. Can we capture host traffic? Sam, yes, that's something that we'll be able to show you. And then I can actually go in and do more full like transaction analysis and that kind of stuff. So I'll get into that a little bit further here. So I'm going to start off in the Explore page in Sysdig Monitor with ECS. And this is just a small ECS environment that we've got running here. So we've got multiple hosts with different containers running on here. And this is kind of like an HTOP for your infrastructure. So what we can do here is actually go and switch this from looking at my environment from kind of this physical view to an ECS native view. So if I switch on over to ECS services, now we're looking at my environment from, okay, let's look at this cluster, the different services that are part of that cluster, and then go into the families all the way down to the containers that roll up into that. You can click kind of on this entire infrastructure overview here, and then get an overview of the different services that are running, the container counts per service, and then get all the way down to looking at, okay, the request times of my different logical services, regardless of where they're physically located, see CPU, net bytes, all that kind of stuff, or get down into your tasks and see which tasks are consuming your most file system, memory bytes, having network activity, all that kind of stuff, regardless of where they're physically running in your environment. Yeah, so Sarat, the same thing's going to happen with Kubernetes, OpenShift as well. Basically, what we'll be doing is pulling the different APIs that you have running, and then enriching every single metric that we collect with the host with all the labels that ECS is exposing, Kubernetes, and all that kind of stuff. And I'll get into Kubernetes a little bit once we go over into the security environment. Jeremy, for services that are fronted by a load balancer, can you monitor the request rate? Yeah, so one of the things that we'll be able to see there is with ALB or ELB, you can see the incoming traffic and then the request from that client to the load balancer, because we'll be integrating with CloudWatch, and also just seeing even like top URLs, slowest URLs, or on the RDS side, being able and looking at the top queries and slowest queries, because we can see that connection and the file descriptor on the system call from that connection that's being opened to RDS. All right, a bunch of other questions just came in. I'm going to try to address some of those at the end and then keep on going through ECS here. So one of the other things that we see from a ton of ECS customers is kind of this crash loopback that you're also going to see on the Kubernetes side. And one of the things that we'll be able to do for you is create alerting in your environment. So there's a couple different types of alerts, downtime alerts, metrics, anomaly detections, and host outlier, group outliers. On the anomaly detection side, you're using ECS because you really care about a logical service. You don't really care about how that underlying host is performing. And so one of the awesome things to do here at that service level is look at the response time of that service as a whole. And then if it, for some reason, gets outside of a standard deviation there, alert on that. Or one of the things that we actually just released is the ability to go and use Lambda or any metric that we collect to then go and schedule new services with ECS and kind of scale out your architecture based on any of the pieces of performance metrics that we're collecting. On the crash loopback side, one of the things that you'll see when you're pushing out a new ECS deployment is basically that new deployment won't fail for a couple hours. So one of the things you can do here is see that if a container is being killed or restarted over and over and over again. And so look for any event that we're seeing. We'll automatically ingest all events from your Docker API or your Kubernetes API. So if a container is killed, if a container is out of memory, if you're scaling replica sets, all that kind of stuff, and allow you to alert on those as well. So if I've had more than 3 containers killed for this specific ECS service in my Go application in the past 3 minutes, I'll be able to alert on that, send an email out to SNS, email, any other notification channel that you've got running there. We'll also have a bunch of pre-built dashboards that you can use. So if you want to go in and look at some of these ECS services or detect anything else that's running in your environment, you just have to get started with one of these, and then you can customize it however you want. So if I want to look at kind of this logical topology or this physical topology of what's running in my system, I can see all those different hosts, which ones are fronted, and then actually go in there, see the processes, how they're communicating with each other, and everything else that's running on that host. All right, hopefully that was a pretty quick overview on the monitoring side. Now let's flip over into Kubernetes and talk about a little bit about Kubernetes running on ECS, or sorry, Kubernetes running on Amazon, and the different things that you want to think about from a security perspective there. Before I flip over, any questions? All right, looks like we've got a couple. So from Vincent, do you install an agent on each node? Yeah, so we install via a daemon set with Kube, and that's going to allow us basically to get those containers restarted. And it's a kubectl sysdig.yaml, and we're going to be everywhere in your cluster. Christopher, yeah, so all the products are REST API driven, so you can send our data anywhere, you can send alerts out, events, all that kind of stuff. All right, so now let's look at an overview of kind of what's running from a perspective in my Kubernetes environment. So I can see the different hosts here where I've had security violations. But what we want to do is really look at these from that logical perspective. And I can use the same idea of grouping here as well and switch it out with Kubernetes now to see the different applications and namespaces that I have running, and then drill into something like this Java app here, see the different deployments, and then the pods that are running in there, as well as the containers and which ones have had violations and dependencies. So kind of a quick overview of all the different services that are connected and their dependencies and which ones might have violations. One of the cool things that I always see with both ECS and Kubernetes customers here is as soon as you install the agents, you're going to start to see all these different connections and really be able to see some service that's talking to a different container or a service that you didn't even know about before. Next, we can kind of look at just a general summary of what's running in my environment and see the policies that are protecting everything, how many high severity violations have happened, as well as the logical hosts where they've occurred, the containers, as well as the different images and services where these violations have happened. Once again, these are going to show up at the service level, regardless of where it's physically located. This is pretty unique on the security side because pretty much every other piece of enforcement is done at the image level. And so if you're using these open source components like Nginx, like Redis, or HAProxy, you name it, the different container images that you're using, if you're using them in different ECS services or different Kubernetes deployments, no other tool can really go and logically break those out at a service-by-service basis and enforce them and enforce different policies that roll up into that logical service that you're deploying to your customers, your developers. So that's one of the things that kind of makes it unique, and so you don't have to have custom images for every service. You can let your orchestrator and the ECS do what it's really supposed to do. Next, I'm going to go through kind of some different policies. So what we're looking at now are all the hosting container policies that are going to automatically come with my environment. These are from the open source community with Sysdig Falco. And so a lot of those have come in that way, as well as policies that we've kind of learned from monitoring and managing millions of containers with Sysdig Monitor. So things like a user running a shell in a container, or if a database spawned a program other than itself, if someone's modifying binary directories, sensitive mounts by containers, all that kind of stuff that's happening at runtime, that could be something that's an anomaly with your user or a program that's running there. But once again, we can go kind of look down in at that service level and drill into this policy that's protecting this Redis service. So right now, it's looking for an unexpected outbound connection from this Redis deployment. And right now, it's scoped to that Redis deployment as a whole. But if I wanted to go and add this to other data services that shouldn't have any outbound connections, then we can go in here and add something like MySQL or MongoDB or any of those other deployments that are running within Kubernetes. And that policy is going to be distributed across the multiple hosts where that Kubernetes deployment is running or that ECS service is running. From here, we can go and kind of stop the container to block the issue, pause it to go and quarantine it and do further analysis, or create this Sysdig capture, which is going to give me all the system calls pre and post policy violation for full forensic analysis here. And you can customize this to see if you want to see the 20 seconds leading up to the event and the 30 seconds after. Really, whatever you want to set that window to, you can customize that for your own forensics purposes. And then these can be sent out kind of to SNS, Slack, webhooks, basically whatever you want running here. Yeah, Kieran, so the agent gets installed on each host and it isn't doing anything with the containers as well. Okay, so next I'm going to kind of go through some of the events and look at things that have happened in my environment, and then kind of go through a full forensics and incident response workflow. So I can see my different namespaces that I've got running here. I can open up this Java application that I've got running, and then go and click on something like this Redis deployment. Switch over to this list view, and I can see the different times it's happened over the last day, and then actually drill in and get further details about what's happened. So we can see, okay, two different policies have been triggered here. So there's an application policy for that unexpected outbound connection, the same one that we looked at and edited before. And then we've got this file policy where a sensitive file was read. The really cool thing here is you're going to be able to see where this happened from that Kubernetes or that ECS lens. So the specific deployment, the pod, which namespace it rolls up into, as well as the host and the container, and the MAC address, all those kind of things. So then you can either kind of shut down that host, do patching, anything like that, of what's happened at that host level. If we scroll down further, you can get actual individual details about what triggered that policy violation with full command line arguments. So we can see, okay, there's an unexpected outbound connection, you've got the command, the ports, and then go down a step further and see that a sensitive file was opened, it's that same ftest command, and then that the file that was actually read was etsy shadow. So someone has gone and started some program has gone and started an unexpected outbound connection, and then it's reading from my directory, which is holding all my hash passwords. So this is something where you'd probably want to go and kill the container right away, or go and do further analysis with a Sysdig capture or something like that. All right, Jeremy, is there a way to integrate Sysdig with your pipeline that when a vulnerability is detected, you can replace the container with a new container that has the latest version? Yeah, great question there. One of the things that we're doing right now is integrating with your CI/CD platform. So basically, any container that you're pushing through there that's trusted or part of your known registry, if some new container is spawned, it'll automatically kill that container. And then you can go and kind of have like a whitelist of the containers that you're going to allow in your environment. And then if a new one is spawned that's outside of that list, you can pause the container, kill it, and then notify yourself. Policy enforcement right now, we're doing through the Docker API. There's a bunch of other different things that we can cover with you individually as well. Jason, other great question here. We're going to be able to monitor really as many, the question was, is there a limit to the number of containers a Sysdig agent can monitor? Yeah, on that side, we're basically going to be able to see every container. So we have customers running 300 to 500 containers per host, really scaling those out across hundreds of thousands of hosts there. And since we can see the C group and namespace that's associated with that container, we're just going to map that back to your environment and be able to pull all that data. Yeah, Kieran, Minnie, Vincent, Jeremy, Jason, awesome questions so far. Everyone else, keep on sending those in. All right, so the next thing I'm going to do really quickly is go through kind of an incident response workflow and kind of go and do deeper, further analysis of what happens when a user does some type of malicious activity on my host. So I can go into this WordPress demo namespace here and then go over into this deployment. And we can see that we had a policy violation for a user running a shell in a container. So since the container is isolated and portable, and that's awesome for a development workflow, also seeing what users are doing inside them is really hard, and they can actually go and execute stuff inside a container that's going to go and have broad reaching effects on your environment. So one of the things we'll kind of look for out of the box is, okay, someone started their shell in the container, let's go and make sure we know everything that they're doing. So what we can see here is saying that full scoping of what happened, the host, the container, and then from here we can actually go in and drill down into the view commands. And now I can see all the commands that were executed when that user started a shell in a container. And we'll have this data regardless of if they just spawned that container, exec in, and then did some stuff and left, all automatically for you. So we can see, all right, the user started a shell, and then they use curl to pull down a URL. So if I click in here, you can get further details that show the entire URL here. So this URL definitely looks pretty sketchy. We've got rootkit in it. So this is definitely something I'm going to want to do further analysis with. You can see the working directory, and then further details about the individual user, the shell distance, the PID, all that kind of stuff. And then from here, we can also go and see that then the user used tar to unzip that rootkit and install it on that container, or on that host from the container. All these commands that you see here are going to be captured all the time, regardless of kind of where you're drilling down to in your environment. And so you can go and drill into a specific namespace, see what users are doing there, what commands are being executed, regardless of where that's physically located. So if you're deploying services with ECS to a developer group, you're going to get full visibility into what the developers are doing, both on those hosts and those services. All right, so now that we've seen, okay, they've done some stuff with this rootkit, they've installed it, they use tar to kind of unzip all those files. Let's go into the capture to do further analysis of what actually happened. So I can open that up here, and we'll open it up with Sysdig inspect in the browser. For anyone who's used Wireshark before, this SCAP file is really similar to a PCAP. We're doing all this analysis outside of production. I can do it on my local machine too. And we're seeing every single system call that happened on my host at that point in time. You can also use all these SCAP files for troubleshooting. It's part of our monitoring product as well. And you can get full performance metrics, network data, file data, app log messages, error messages, all that kind of stuff in this centralized troubleshooting and forensics location. So first off, let's go and overlay this security violation that happened. So I can drill down into it, see it's the same violation that we had before, and then start overlaying my executed commands. Look at that specific time window when it happened. Okay, cool. It wouldn't be a live demo if something didn't go wrong. So thanks for staying with me. We can overlay the Sysdig secure notifications there, look at the executed commands, and then kind of drill down into that specific window and start overlaying other pieces of related data on top of that to do further correlation and all that kind of stuff. From here, we can actually go into those executed commands, see the same commands that we saw in the commands history, but then from here, go and actually do further analysis of what happened when that user ran tar. So I can double click on the command and then switch over to this files view. And what I'm looking at now is every single file that was installed when tar was ran to unzip that rootkit. So we can see the README, the install script, the backdoor, every different file that was installed. And then actually go in a step further by using the IO streams functionality here and see the individual contents of what was written to that file when it was installed on the host. So from a forensics side, I'm getting all of this data about what happened, what the user did, and the individual contents of the file, of the HTTP transaction, of basically anything that's happened from this capture file, pre and post policy violation. And all of this can be automated and triggered off of any alert on the monitoring side or any security violation on the security side as well. So this is another time where we usually see a ton of questions, and it looks like there's some here. Okay, is there anything we're seeing here specifically reliant on AWS for the introspection, or it works equally well on bare metal? Yeah, so we're going to be able to monitor anything Linux and be able to see all those system calls, take those captures, do all that kind of stuff. For the AWS side, where AWS is really awesome and where we can pull in that metadata from CloudFormation or any of the AWS tags or things like that, where we'll allow you to do the different service-based policies and all that kind of stuff. All right, Corey, another question. is there a config to get the introspection and feed it into our own monitoring system or analysis engine? Great question. So one of the things that I kind of covered in the slides is we have two ways where we can store this data. You can store it in our SaaS backend and use this as a SaaS service, send that all out via API, or you can deploy it on-premise and use all of our data is stored in Cassandra for the performance metrics, and then events and user commands and things like that are all going to be stored into Elasticsearch there. All right, Michael, I love this question. This is magic. How many wizards were sacrificed to make this possible? Michael, only 3. We thought it would take 4 or 5 wizards, but 3 got us what we needed. Yeah, so on the Sysdig and spec side, this is fully open source. You can download it, play with capture files locally, check it out. But the thing that gets really valuable here is all of those policies and captures can be automated. But sorry to any wizards in the audience. We didn't mean to sacrifice as many of you, but had to do it to kind of make Sysdig and spec. So Michael, awesome question there. Thank you. I'm just going to go back into Sysdig monitor really quickly, and then look at our event feed. That's one thing I kind of realized I missed. And then from there, we're going to open it up to questions for everyone. So in this event feed, you're going to be able to see all custom events that have happened. You can deploy in anything from your CI/CD pipeline, all of that automatically, and get kind of full context about the host, your specific container, all that kind of stuff, even with exit codes. So that's one of the huge things that we've kind of seen is like, this container randomly died. What happened? And those exit codes and things like that are going to allow you to actually go and do some deeper troubleshooting there. All right. With that, thanks everyone for attending. You guys have been an awesome audience. I've loved having all these questions come in interactive. We're going to open it up now for anything else that you want to ask, and let's go from here.
All right, awesome, Knox. That was a great job. Very risky of you to do so many live demos in one webinar. So it's really cool to see. Really cool to see the functionality of Sysdig for monitoring these container workloads. I think you answered a lot of the questions that we have in the feed. So if anyone's got any, please keep them coming. But I think one in particular here, I don't know if we addressed, is there any APIs that allow other tools to consume the Sysdig data?
Yeah, so we have a full REST API for forwarding any of this data out, as well as Python clients to pull this data. The other question that I can see here is, are APIs available to consume data with Splunk? We have a Splunk integration where you can send data in as well. So all of that will come in.
Awesome. I think another question I think maybe was asked earlier that we may not have addressed. What user does the agent run as?
Yeah, so the agent will run as a privileged container or a root user on the host. We do need that access so we can load that module, but the module is fully open source, and you can see all that kind of stuff.
Yeah. Can you describe a hybrid cloud deployment architecture or multi-cloud?
Yeah, so you can really deploy our agent on any different host, whether it's running on-premise, on AWS, on your own private cloud, on a different public cloud, and then we're going to forward all that data to our backend. So we have customers, we actually have a lot of European customers that are doing stuff in the AWS Frankfurt region, as well as some on-prem data centers, and that's allowing them to kind of send both pieces of data to our backend and monitor it from there. So really, you can kind of run our agent basically anywhere as long as it's Linux.
Great. Let's see here. I think we've got time for a couple more. Does the service have any built-in IDS capabilities, or and I think you answered, can you feed into a third-party IDS?
Yeah, so we have some intrusion detection capabilities kind of based on the activity that's happening on the host. And so looking at like if a process is started, if some user runs, those kind of things. And then kind of with any other piece of data that we collect, like I've said before, we can send that out anywhere.
Okay, great. Let's go ahead and take one last one here. We know that Sysdig has some open source products, but on the commercial offering, what does the pricing look like?
Yeah, so the pricing for Sysdig Monitor starts off at $20 a host a month. And then we have different pricing tiers kind of based on how many containers you're running or different pieces of functionality like teams or the metrics limits and things like that. But since we're not a tag-based system on the metric side, we're going to be able to collect thousands of metrics from your hosts and containers out of the box.
Cool.
And then,
on that note,
yeah, okay, awesome.
Yeah, I think we're going to go ahead and wrap it up. Thank you so much, Knox. Great job. Just as a quick reminder, you'll get an email within the next few days with a link to these slides on SlideShare and a recording of the webinar. It'll be posted on our AWS YouTube site. Just wanted to thank everybody very much for attending. And if you have any other questions, please don't hesitate to reach out. Thank you.
All right. Thanks, everyone. Thanks, Omar.